Now we consider one example. Uh, Before starting it, I just want to recall it that the Laplace of function ft is always the function of s. Now in the inverse Laplace, we are having always the function of s and we require to find out the function of t. Now if we consider the first example, that find the Laplace inverse of 1 over s square minus 9. So to find out the Laplace inverse of this, we just check from which formula it is matching, like 1 over s square minus of a square is somewhere in sine hyperbolic at or in cos hyperbolic at. But when we are saying for the cos hyperbolic at, cos, that means in a numerator it should be s, and for the sine it should be a. So over here we have to remember that we are not allowed to multiply or divide by small s. So over here what we do, we are going to multiply by 3 and divide by 3, because this will be converted into 1 over 3 and 1 by 3, 1 over 3 and 1 by 3 into s square minus 3 whole square. So finally this will be the complete formula and constant will be exactly same, that means 1 by 3, and this will be converted into sine hyperbolic 3t. Similar, suppose we are having a similar question like Laplace inverse of 5 over s square plus 19. So because in a denominator we are having a sign of s square, from this s square we are getting that the formula is going to be converted into either in the sine or cos. From this plus we are getting that the formula is for simple sine or cos, not a hyperbolic. In a hyperbolic we have negative sign, but in a simple trigonometric function we are having a positive value. So can we say that the Laplace inverse of 5 over s square plus under root 19 square. So what we required, we are not allowed to multiply and divide by small s. So but we are allowed to multiply with under root 19 and divide by under root 19. So what we get, 5 over s square plus under root 19 whole square. Now to create the complete formula for this, we are taking these portion along with, and we get the value of 5 over under root 19 is a constant, and this will be converted into sine under root 19t. So this is the solution for this problem and for this problem, and this is the solution for the first problem. This is for the first and this is for the second. Now we are considering a different example, that Laplace inverse of 5s minus 10 over 9s square minus 16. So by looking this question, we can say that in a denominator it is s square, so it is going to be a formula of sine or cosine, but over here it is negative, so it is in a sine or cosine of hyperbolic. For this portion, can we say that splitting it as a 5s over 9 s square minus 16 is the first part, minus 10 Laplace inverse 1 over 9 s square minus 16 is the second part. Now for the first portion, what we require, in any sine or cosine function s square is always multiplied with 1. So we have to consider 9 as a common term. So Laplace inverse of 5s over 9 is considered as a common, then s square minus 4 by 3 whole square minus 10, and Laplace inverse of again 1 by 9 is common, then s square minus 4 by 3 whole square is the second term. Now denominator is clear. To convert the numerator, we just take 5 as a common. So 5 by 9 Laplace inverse s over s square minus 4 by 3 whole square. This will be converted into a simple formula minus 10. To solve this, we require 4 by 3 over here. So just we multiply by 4 by 3 and divide by 4 by 3, and 9 is common. So the value is s square minus 4 by 3 whole square. Now again for the solution, this will be converted into cos hyperbolic, that means 5 by 9, and this is the cos hyperbolic 4 by 3 t. For over here, this is the numerical term. You just calculate yourself. 4 by 3 into 9, and the remaining term, this will be converted into sine hyperbolic 4 by 3 t. So for the problem, for the given problem, the Laplace inverse of the function is this value. You have to remember always that you are not supposed to multiply or divide by small s. You can multiply, divide, and even do partial fraction only for the numerical terms. Now we are taking one more example, that find the Laplace inverse of 2s minus 5 over 4s square minus 25 plus 4s minus 18 over 9 minus s square. So to find the Laplace inverse of this, we are again splitting it into 2s over 4 is common, s square minus 5 by 2 whole square. Remember, when the s is separate, we are trying to convert this part into a cos term, minus 5 Laplace inverse 1 over 4 is common, s square minus 5 by 2 whole square plus 4 over minus 1. 4 over minus 1 is common. Laplace inverse of s upon s square minus 9. Again minus 18 over minus 1 is common. Laplace inverse of 1 over s square minus 9. So finally, to convert the Laplace inverse formula completely, this portion is 1 by 2 Laplace inverse of 1 by 2 Laplace inverse of s over s square minus 5 by 2 whole square minus 5 by 4, and over here we required 5 by 2. So Laplace inverse of 5 by 2 multiply and divide by 5 by 2 s square minus 5 by 2 whole square. This is converted into Laplace inverse formula of hyperbolic sine 5 by 2t. Now over here, for Laplace inverse of s over s square minus 9 is converted into cos hyperbolic 3t and plus 18 Laplace inverse of 3 upon 3 s square minus 9, and this will be converted into sine hyperbolic 3t. So finally the solution for the given problem will be 1 by 2 and cos hyperbolic 5 by 2t minus 5 over 4 into 5 by 2 Laplace inverse of sine hyperbolic 5 by 2t minus 4 cos hyperbolic 3t plus 18 by 3 sine hyperbolic 3t. So this will be the solution for the given problem. Now I am considering a one case for the Laplace inverse of function fs over s when 1 over s is separately in denominator. This will be equal to integration 0 to t of ft dt. Remember, for this fs, whatever we get the Laplace inverse is ft. So now, considering one example, Laplace inverse of 1 over s into s square plus a square. So it is clear this portion is easily converted into sine, and 1 by s is remaining. So Laplace inverse of 1 over s is separate, s square plus a square is required. So we multiply by a and divide by a. So this will be Laplace inverse of, for considering this complete term, 1 by a is common, integration 0 to t, and this is equal to a function of sine at dt. So integrating sine at dt, we get 1 by a, integration of sine is cos at over a, negative sign with limit 0 to t. Now 1 by a square minus is common, so cos at to the power 0 and limit 0 and t. Now finally we get minus 1 by a square and cos at, because we are putting this limit for t, or t is replaced by t, cos at minus cos 0. That means the result is minus 1 by a square cos at minus 1 is the solution for the given problem. Now a few examples which is required to be done by you is s square plus 2 over s into s square plus 4. Find the Laplace transformation of this. Now a few questions is required to be done by you to understand the complete concept. Find the Laplace inverse of s plus 2 upon s plus 2 whole square minus 25. Second is find the Laplace inverse of 6 by 2s minus 3 minus 3 plus 4s over 9s square minus 16 plus 8 minus 6s over 16s square plus 9. And third question is find the Laplace inverse of s over s square plus 4s plus 13 plus 13. So you have to find out for which term 1 over s minus a is required. Split this part might be possible over here. You are going to use the formula of e to the power at into sin bt or Laplace of e to the power a2 into cos bt, or might be possible a hyperbolic function. That means the first question is similar to shifting theorem, inverse problem of shifting theorem. So that's all for today. You have to do these practice questions, and for any doubt and any query, contact your class faculty regarding your doubt session. Have a nice day, stay safe, stay home.